Hi, it's Helen Dakin again. I'm back this time to discuss with you calculations involving present value for annuities. The present value of an ordinary simple annuity is simply the discounted value of all of the annuity payments. This discounted value occurs exactly one payment period before the first payment is made. So you can see that from a time diagram that I have here, we have a series of regular and equal payments made at the end of every interest period of R dollars, or in the case of the BA2 Plus calculator, we will use PMT to represent the payment, but we have payments of R dollars at the end of every interest period, and for end periods, the focal date for the present value is with today's date, or at least that is one interest period before the first payment is made. And this is absolutely critical. The formula for the present value is given below. PV, or present value, is equal to the payment size multiplied by the annuity discount factor. And that discount factor involves a negative exponent. You will see that the discount factor is very similar to the compound accumulation factor for annuities, except that the exponent is negative, and it's 1 minus 1 plus I raised to the exponent negative n divided by I. Let's move on. So this is what a time diagram looks like for an ordinary simple annuity, where we are setting the focal date to be today's date for the present value. If you explore your BA2 Plus financial calculator a little bit closely, you will see that there is a row again devoted to the annuity functions, and that row will have PV for present value, PMT for payment size, N for number of payments, IY for the nominal interest rate, and again, in order to enter the compounding periods per year and the payment periods per year, you'll have to enter second function IY. CY is going to be for the interest compounding periods per year, and PY is always to the payment periods per year in our ordinary simple annuity. So learn how to use these functions. Ask for help if you need any help in calculating. Example 1. Determine the cash value of a contract with quarterly payments of $6,500 over a 4-year period at 9% compounded quarterly. So in this particular case, as we always do, we'd like to start with a timeline or a time diagram. It's very important. Without the time diagram, we don't have any perspective. Let's start with that. Let's see. We have quarterly payments of $6,500, and they're made over 4 years. Quarterly payments over 4 years, that means we've got 4 times 4, or 16 quarterly payments of $6,500. So let's start with the fact that there are 16 quarterly payments of $6,500 at the end of every quarterly period. So here they are. The time diagram is beginning to take shape. We've got $6,500 payments at the end of every quarterly period, and there are 16 of them. The interest rate is 9% compounded quarterly, so that boils down to 9 divided by 4, or an interest rate of 2.25% per quarter. So I is equal to 2.25% per quarter. And I like to indicate the fact that the interest rate is per quarter because those words help to remind me how the interest rate is compounded or calculated. And the payment, of course, the payment is $6,500 per quarter. And this is an important fact, the fact that these two coincide. They're made with the same frequency. An ordinary simple annuity is one where the annuity payments and the interest periods coincide. They don't conflict. I'm going to start by talking to you about the annuity bus. So I'm going to wrap an annuity bus around this annuity. So we've got here a little shape of a bus taking shape, and we've got a wheel underneath the first payment and a wheel underneath the 16th payment, or the last payment. We want to determine the cash value of this contract with quarterly payments of $1,600. The cash value means today's value, cash in the hand. So the cash value and present value mean the same thing. Cash means present value. Remember that. And the present value of this annuity is simply given by the product between the annuity payments and the discounted factor, the discount factor for an ordinary simple annuity. So we've got $6,500 per quarter is the annuity payment multiplied by the compound discount, the discount factor for that annuity, which is 1 minus 1.0225. The exponent is negative 16. That negative 16 corresponds to the number of annuity payments divided by 0.0225, the interest rate per period. So, summarizing again, this is per quarter, $6,500 per quarter. The interest rate is per quarter, and there are 16 quarterly deposits. Nothing conflicts. Everything is in sync, as we say. So we've got an ordinary simple annuity, and we want to find the cash value or the present value. Determining that on your calculator, you will end up with a present value of this ordinary simple annuity of $86,532.10. So we've got $86,532.10. Another very important interpretation of cash value or present value is that what it's telling us is that if we had $86,532.10 in an account today, earning interest at 9% compounded quarterly, we could make quarterly withdrawals from that investment or from that $86,000 account every quarterly period for the next 4 years before we ran out of money. So after 4 years, we'd have $0 in our balance, but our opening balance would be $86,000.